Assalamualaikum and hi, my name is Nurul Farawaida binti Norman. Metric number is CE2300005. Today I will present about project multivariable calculus for the question number 1 about double integral application. For 1A, finding the area of a region. Given the equation of two curves y equal to x squared and y equal to 2x, perform the following task. For the number 1, draw the region bounded by the given curve. And the second is use a double integral to find the area of the region. For the solution number 1, I use the xy projection to find the dy and dx. For the dy, x squared until 2x and dx 0 until 2. For the question number 2, use the formula of area is equal to double integral 1 dx. For the solution, insert the dy and dx into the double integral and find the final answer is equal to 4 over 3 unit square. Next, for the software simulation, I use the MATLAB. First, define the bounds for y and x. Y lower equal to x squared, y upper equal to 2x, x lower equal to 0, and x upper equal to 2. Second, set up the double integral to calculate the area. Third, display the result. Fourth, plot the region. Fifth, create the plot. And then lastly, add label and title. So the answer for the area is 1.333, and the beside the coding is the result after we run the coding.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Masyita binti Harun and my metric number is AE2030033. So here are the menu calculation for the question 1B. So if we see this question, it's given the parabolic z equal to x square plus y square and find the surface area of the parabolic in between z equal to 16 and z equal to 4. So we have the equation here, x square plus y square equal to z square. So before we substitute into the formula for the surface area for the paraboloid, so we need to define the dr and d theta, fy, fx, and fz. So here after we find in the equation. So the dr is 2 until 4 and d theta is 0 until 2 pi. So f equal to z and z equal to x square plus y square. So in the difference shape for the fy, we get the 2y and fx equal to 2x and fz equal to 1. So we substitute this value into the surface area into the formula. So after we substitute, for the double integral surface area, square root fx square plus fy square and mz square. For dA is the surface area. So we need to define and substitute, and we get the 230.69 unit square to get the same to prove the answer in the menu calculation. So the first statement is define the integral. So we need to define the R minimum, R maximums, and F equal to integral in the polar coordinate. And step 2 is we compute the integral. So here are the theta, integral 2 pi means like 0 until 2 pi, and the radial integration. So I already comment in the beside that. So and then this formula for the surface area. And then the step 3, we need to display the result. So the surface area of the parabola, so we display lah. Then this step 4 is we need to visualize the paraboloid to make clear where is the surface area. So here are the coding for the data line space 0 until and that's all. And the last is figure. So figure is to make clear the how the surface area for the paraboloid. So here are the codings. So we have x label, y label, z label, and the title is parabolic surface from z equal to 4 until z equal to 16. So if we run, we get the paraboloids. the surface area of the parabola z equal to 4 and z equal to 16. But I forget to show you guys the answer for the coding. So we get 237.69689737 square unit. So it is same with the answer in the manual calculation. So I think that's all from me, and thank you.
So next we go through to the next question, question 1C. So for the question 1C, finding the volume of a solid, use double integral to determine the volume of Z equals square root 4 minus x power of 2 minus y power of 2. So this is the manual calculation for question 1C. So in question 1C, we have 4 steps. For the first step, we analyze the solid. After we get the analyzed solid, we just sketch the sphere, and then we use the double integral formula. The double integral formula is V equals double integral ZE. After that, we simplify to get the angular part, and then we use the product rule to get the answer, and then we just find the new limit for the product rule, and we simplify again, and then we just combine the result, the answer we get for angular part and the answer we simplify, and the answer we get is 16 pi over 3, like B 16.7551 units. And next we go through to the software simulation for question 1C. So in this question, we just use MATLAB to do the simulation. The coding have 5 steps. So for the first step, coding to define the integral, and the second step, the coding define the bound to the lower and upper region, and then for the third step, the coding compute the volume, and the fourth step, the coding display the result, and then after that, the coding visualize the solid, and after visualize, we get the answer and of the solid bound, and the sketch is like this. And in the sketch, we have z axis, y axis, and x axis. So the answer for the question is seems like the manual calculation. So for the next question is question 2A. So the question 2A, we want to find the volume of the solid in the first octane which bound by xy plane, yz plane, and the plane x plus y is equals to 4 and z equals x power of 2 plus 6. So we go to the manual calculation. So in the manual calculation, we just want to find the x position and z position and y position, and the sketch is like this. And then in the calculation, we have 4 steps, and for the first step, we just want to find the bound x and y, and we use the triple integral formula, and then after that, we just simplify the integral, and after that, we get the term after we simplify the integral, and all the term we just combine, and then we get the answer. So the answer is 208 over 3, like 69.33 units. So next we go through to the simulation of question 2A. So for the simulation, we use MATLAB, and then in this coding, we can know the coding just calculate the volume to get the visualized or to get the 3D sketch, and then after that, it display the result after they calculate the volume. After the coding display, the MATLAB was give the 3D visualize, and in 3D visualize, we can see the flat sketch and the curve sketch like this. So in the 3D visualize, we have Z axis, Y axis, and X axis. So that's all for me. Thank you.
Hi, let's move to the next question, which is 2B. So from the question, we can determine the value of dz, dr, and d theta. For the dz is between r square and 1. For the dr, we use formula circle, which is square root 4. So we get 2. So the value is 0 to 2. For the d theta, it said first and second octane. So 0 to pi. Then we put the value into the formula. V is equal to triple integrate 1 dz dr d theta. So we calculate, and the answer we got is negative 2 pi for the value of volume. We cannot get the negative, so we change into positive, which is 2 pi. Let's move to the simulation. First, we put the value of bound that we got from manual calculation. Then, we define the formula of volume using triple integration. Then, we display the result. For additional, we can visualize the 3D region. So first, generate a mesh grid for plotting the paraboloid and plane. And next, we plot the 3D region. We also can put any color that we want. Thank you.
Hello everyone, my name is Muhammad Wazir bin Danilo and my matrix number is DE2030337. So we will continue with our last question, which is 2C, and the question is calculate the volume of region which bounded above by spera of x squared plus y squared plus z squared equals to 81 and below by con z equals to square root x squared plus y squared in the first octant. First thing first we need to do in the question is we need to sketch. So you can see at my screen I already sketched the spera and the con, and by using the formula triple integral 1 phi square sin rho d phi d rho d theta, we need to find the interval of phi, rho and the theta. So we can know the phi is 9 because the formula of phi is x squared plus y squared plus z squared equals to phi squared. So we just square root the 81 and we got a 9. So phi is from 0 to 9. And next, by using the equation of con z equals to square root x squared plus y squared, we can find the rho, and you can see that I already calculate and we got the pi over 4. So the rho is from 0 to pi over 4. And by C at the top of my sketch, you can see it is round, is circle. So, but the circle is, we just need the first octant. So the first octant is pi over 2. So our theta is 0 to pi over 2. So we put at all the information that we got in our formula, and we got the answer is 111.798 unit cube. So to make it sure our manual calculation is correct, so we use MATLAB to simulate our question, and we got the same answer, which is 111 and 0.793. And you can see my MATLAB also give the 3D visual of bounded region, and you can see the first octant of our question. So that's all for me. Thank you.